George Fraser, thank you for joining. So for context, George, founder and CEO of Fivetran, which is Fivetran was founded in 2012. Is that right?
That's right.
And $5.6 billion private company most recently. George has the unenviable distinction of being the only founder I've given 2 term sheets to and still not had the chance to work with. But he is one of my...
Come on, I can't be the only one.
I think the only, like anyone else, I had enough pride to be like, I'm not giving this to you but with you, I was just like, your business is so good. I don't care if you say no, right? So George, maybe tell us what does Fivetran actually do in your words?
Fivetran goes and gets all the data of your company's data from all the places that it lives. So your Salesforce instance, your finance system, your production database, your everything, your ad networks, and we make a copy of that data in your data warehouse. And then we keep that copy up to date continuously as the data changes in the source systems, or as long as you keep paying the bill. And then you can use this data to understand what the heck is going on in your business.
So, one of the things that we were just talking about is, to your point on the Microsoft coming in with Teams and Slack and Scale. I know when you were fundraising in the early days, there were a lot of people that said, hey, wouldn't Amazon just do this? Won't Microsoft just do this, right? And there was always this threat, both from VC's perspective, right? But also like actually this threat of a competitor coming in all the time and offering this. And so we were just talking about the Microsoft example with Slack, but that was something you guys, had to get around for a long time, right?
It was the big thing people were worried about for a long time. And the one answer is they have, but they're just not very good. And this is actually a really hard problem. And it's not hard in the way that most hard problems are hard problems. Like, making an analytical database like Snowflake, that's something people do PhD theses in. What makes Fivetran hard is not like any single deep computer science problem. It's just this tremendous amount of incidental complexity that we have to deal with in order to, because all of these data sources are very quirky. And the thing that makes Fivetran great is our willingness to run down all of these little quirks so that you as a user don't have to understand how this all happens. You see, your charges table in Stripe, and you don't have to know that Stripe contains an eventual consistency bug in its events API endpoint that only comes up once in a blue moon at extremely high transaction volumes. And every time you pull it, you have to go back an extra 60 seconds from the last time you pulled it to make sure that you cover for that bug, which we discovered because a customer, a big B2C customer, ran into it years ago. That bug took 2 years to discover. That's kind of an extreme case. That was probably the hardest to chase bug we ever had. And our willingness to do that is what makes Fivetran special.
Yeah, and there's this economies of scale to that where now when you get more customers, you're spending more time QAing these things for your customers, right? And so it's not like a hard, I'm sure it's a hard math problem, but it's also just like it's a lot of fucking work, right?
It's a huge amount of work in it, but it does have this incredible, as you put it, this QA economy of scale, because we have many customers who are using all the popular connectors. And so we get many chances to observe the same bugs. The other interesting phenomenon in our space is that the less popular data sources always tend to have cleaner APIs. It's funny. It's the strangest observation, but it's like, if your API is beautiful and perfect, then your business is terrible because you were spending too much time on your API or something. I don't know why this is, but it's like a universal principle out there that like the best APIs have hardly any customers. And so the fact that we don't have the QA economy of scale there is actually sort of okay.
It reminds me so much. We had the Plaid founder one of the two Plaid founders who I've known for a very long time on a while ago, just talking about like the long tail of just like shitty data integrations they had to do, and that's obviously what drove the value there. And I asked him this question I always like to ask founders, is just because it's like the inside baseball no one ever figures out, is like, was there a product decision early on in the cycle that you can point out a little nuanced product decision that you felt drove the differentiation between you and the, I'm sure, 10 other companies that were trying to do something similar and the big guys who were trying to do it poorly? Was there one thing or two things that really changed the game, or was it just like chasing each one of these edge cases down?
Well, there is an answer to that. But first, I just want to say that Plaid is a good analogy. Plaid is very similar in this regard. And I've met the Plaid founders and discussed this with them. Our companies are sort of cousins. There's another cousin company in this group, which is Zapier, very similar. And we've talked to the Zapier founders. We've even compared notes about how we do like troubleshooting processes to try to learn from each other. And there's yet another cousin company who sort of pretends not to be one of us, and it's Stripe. Stripe, a lot of what they're actually doing behind the scenes is dealing with all of these different like banks and credit unions and stuff, and they're basically maintaining integrations to all of these financial institutions. But I think they don't like to let people know that that's what they're really doing back there. So they kind of pretend that they're solving something more glamorous, and they don't. They're one of us, but they pretend not to be. But to answer your question, there was a key product decision, and it was delivering a normalized schema, which is a little bit like in the weeds of data stuff. But when you deliver data to a data warehouse, traditionally you deliver the data in what's called a denormalized schema, where it's optimized for consumption. So you have relatively few tables, like a simple schema, relatively few tables, lots of columns on each table, and it's just easier to understand and work with, and that's why you do it. The problem with this is that everyone's denormalized schema is different. A denormalized schema that works for one company is not going to work for another company, because the simplification that you are imposing on the data is always sort of domain specific. And so what we said is, well, and because of this, every ETL tool ever made was highly customizable so that everyone could have a different schema. And then that meant fundamentally you didn't get that QA economy of scale, because everyone was doing something a little bit different. These things were basically platforms. They were not actually selling, something that you could just take out of the box and use. So denormalized schema was the traditional way. We did something really weird. We said we're going to deliver a normalized schema. We're going to deliver the data in its full complexity, one table for every concept. And it's going to, there's going to be some work there when you have first contact with the schema to just understand what all these things are. But the huge advantage of this is that the normalized schema is the same for everyone. So we could build standardized connectors where everyone is truly running the same code. And then we got this QA economy of scale. And then after a couple of years, it started to really work well.
Do you know, like, were there specific competitors, because you guys have been around now for about 10 years, along the way that made a different decision or went a different route, and you felt like you could tell it hurt them in market, and now they're whatever, fifth place or not around? Like, was that clear?
Well, in the early days, our big competitor was Stitch, who eventually sold to Talend. And I got a great quote secondhand, so you'll have to fact check this with him, whether it's actually true, but from Bob Moore, who's now running Crossbeam, which is a really cool company. But he said that he sold to Talend because he said, I just didn't want to spend the next 10 years of my life competing with those guys fixing bugs. I was like, yes, that's right.
That's actually a direct quote, and I'm the one that told you that. So I will take. So I'm on the board of Crossbeam, and he said that Bob's the best, but he said, like, that's a really fucking hard problem, and I'm gonna have to spend my next 10 years of my life like just QAing all this stuff. And so, I mean, you guys were both like so early to the cloud and indexed to Snowflake and Redshift and all these trends, right? And Bob, I don't know how much he says that tongue in cheek, but it is pretty funny.
So we were both like right there at that, in some of those, in that key early year of like 2015, 2016. And the different decision that we made is we said that we are going to promise that the data will be 100% correct, and we will chase all the bugs, and we will design a normalized schema that is possible to deliver for each data source. And Stitch said, we're going to make a slightly less ambitious promise. We're basically going to say, we're going to call the API endpoints, and whatever comes out, we're going to load into the data warehouse. And that's kind of the definition of our job. And if that does not result in a correct replica, well, that's kind of the source's problem. That's not our fault. That's the source's fault, which is fair enough. And that was like a critical decision that we each made differently. And then it took a while for that sort of bug fixing flywheel to do its thing, but eventually there was this pretty significant quality difference in the correctness of the data that you would get with Fivetran versus Stitch. And that, I think, allowed us to pull ahead in the long run. But it was not obvious in 2015 or 2016 that was right.
When you were making that call, who was in the room on your team? Like, how did it happen? Like, was it a real debate? Was there a spec? Was there because what we asked William the same question about, he has a different version of the same answer and in their context. And his take was, everybody thought I was wrong and I wanted to do it anyway. And so we did it and here we are. I'm curious what your version of that looks like.
It was only 3 of us at the time. And it was me and Taylor and Mel.
Oh, so this was early. This was really early in the design.
And we never considered the alternative. We were just like, well, this is how it has to be. We have to take responsibility for correctness here, because people were filing bug reports and we were like, well, that seems like a bug. I guess we should fix it. That was it. It was never, we never actually perceived it as a decision.
They're like, hey, listen, we want this to be right.
The reality is there's a whole other category of work that we abdicated and said, we're not going to touch that. That's your problem. Which is like rationalizing the data that comes out of the system. There's all these crazy properties that the data has, like in Salesforce, like if the account is this one particular ID, like that's the test account. And so whatever you see for that, you got to filter it out because that's not real revenue, that's test data. And that's like a super simple example. The realities are like way more complicated and horrible. And we just said, like, we're not touching that problem with a 10-foot pole. Like, we deliver the data. If it's a correct copy of the source, our job is done. And then you have to go and figure out, like, how to make sense of all this. And that was also different than the traditional ETL vendors, where they would tackle that. And they would say that was the primary value, was tackling that problem. And so they would use the same tools to solve the sort of business rule problem and to solve the like data integrity, correct replication problem. And what we did is we came along and we said, okay, the business rule problem is actually impossible for a vendor to solve. Like, only the customer can figure this out, and they should use like a different set of tools to solve this problem. Basically just SQL queries. We looked at it, we're like, the SQL queries that come with your database are the right solution to this problem, and we have nothing to add. Eventually DBT would actually add something big to that, but we were like, yeah, we are declaring this problem unsolvable, and we're not getting involved. And then this other problem, we're declaring it completely solvable. We're saying, not only are we going to solve it, but like, you don't even know about it. Like, if you observe any violation of correct replica, that's just a bug, and you just tell us and we'll go fix it. So it was like triage. Sometimes it was like selling outcomes, but the outcome is a correct replica in your destination. And the outcome they actually care about is, the answer of how much revenue did I actually book in, the Western region in the growth segment for the new product that I just launched last week. And like,
the business rules,
there's still a long way to go to get to that, but we can't get you all the way to that outcome. You have to do that.
When you were first going to, like, obviously there's the technical component of this, of I've got to like connect all the source systems. I got to deal with the weird edge cases in their APIs or where the documentation is wrong. But then there's the use case that drives demand. What did you think it was going to be? Like, was it a marketing use case or sales and the actual business case behind it? And then what did it actually turn out to be that drove the what I think of as the first stage of demand, the people recognizing, ooh, this is actually a problem I want to solve.
Salesforce was the original tentpole connector. That was the most popular connector for so long. For years, it remained the most popular connector. And now, depending on how you measure it, it's been displaced by ad networks or by databases. But that was the original tentpole. You'd always go after Salesforce first. Get me a copy of all my Salesforce data in the data warehouse. And it's sort of interesting because Salesforce is kind of an exception to that rule about what I said. The best businesses have the worst APIs. Salesforce's API is really pretty good. It's funny. People often complain about it and they're like, it's so hard to write a Salesforce connector. And I'm like, are you kidding? Like, have you tried writing a Marketo connector? Salesforce is nothing. So it was, and Stitch's Salesforce connector was good. That's part of why the competition was so close run for those first couple of years. They were pretty similar. It was not much different. Well, and that was the tentpole. That was what you would go in with. So it was like, well, in the second month, our connectors are better. That's a hard edge to drive, right? So that was the original, first connector everyone would set up.
Sorry, now I'm really curious. Was it like they just wanted the Salesforce data so they could write SQL against it and they didn't want to understand the API, or was it they wanted to merge it? Was it like I always thought that the idea was like, I want to combine with X other data set and you can provide both the ETL for, the combination of the two. Or was it really just, I just want my Salesforce data?
Yeah, at that time, probably for most people, it was just, I just want my Salesforce data. I just want to be able to write a query against my Salesforce data and have it run fast. I mean, literally, that was our first customer, their use case. It was like, our first customer was Zenefits.
Was there never a question at Salesforce of like, hey, we'll build this as like another product that we bundle up, the data warehouse representation of your data that's really fast? They just never considered building it?
They've had for a couple of years. The problem is that they haven't done a good job with a bunch of things. I shouldn't say exactly what, because I don't want to help them. It's funny. I always kind of assumed that they would. I actually modeled this in some of our funding rounds. It's like, okay, if like Salesforce builds a high quality connector, how much of a problem is that for us? How much do we lose? And it was like 5% of our revenue or something. And because by that point we were pretty diversified, right? It was still the most popular connector, but nonetheless, it was the most. There were hundreds in the race, right? And the funny thing is, to this day, their connector kind of sucks. They've gotten tripped up on other aspects of the problem.
Interesting.
And we continue to make our Salesforce connector better. Like now we have support for formula fields, which is truly unique. We wrote a formula field to SQL translator so that customers could get formula fields in their data warehouse, which we're the only ones who have ever done that. That was like the equivalent of building 10 connectors, that project.
One of the things I think is interesting about your company is you had a fairly normal start to it. Going through YC. And then when we got to know each other, when you raised a Series A, from that point on, it's been pretty serendipitous and pretty normal. But the period in between there, and I don't know exactly what it is, 2013 to 2015 or something, 2012 to 2015, you iterated quite a bit, right? What you went to YC with was very different than what you ultimately kind of iterated on. Can you take us through that journey of going with MATLAB in the cloud to Paul Graham to, actually finding product market fit, what that path was looked like and how you actually went about doing it?
Well, MATLAB in the cloud, which was the original idea, lasted all of about a month. Although that is where the name comes from. If you think about it, Fivetran, which is a pun on Fortran, makes a lot of sense as a name for MATLAB in the cloud. That did not last long, though. It became pretty clear that I was the only person in the world who wanted that. It was like what I would have wanted as a scientist. That's what we were making, and then it was like, okay, I was actually the only one. And the funniest thing is, we actually met two guys who had tried the exact same idea a couple years earlier. We were introduced by Warren Hogarth at Sequoia. And now I forget the two guys' names, which I feel so bad about. Great favor he did us, and they did us, because they just went through it, and everything they described is this was our exact plan. This is actually better than our plan. We were learning a bunch of things that we would have taken 6 months to figure out, but it did not work whatsoever. And they described exactly how it did work. And that doesn't mean that just because someone tried it before and it didn't work doesn't mean it can't work. But in this case, it was we have no answers to the obstacles you ran into, and there was some other evidence that we were on the wrong path. So we pretty quickly dropped that idea, and we said, okay, we're going to make a vertically integrated data analysis tool for business people. And then that was the start of a long series of iteration. So it was spreadsheets for big data, and then it was more of a BI tool. And data integration was part of that story. So data integration was part of that stack of what was inside what we were working on for those whole 2 years. And then eventually it became clear that if you stripped it down to just data integration, that was something people actually really wanted. But that was because Redshift came up. See, we were too early for Fivetran. Like you couldn't have made Fivetran in 2013. If I could go back in time, I would have to tell myself just like wait around for a little while, like practice programming. Like the year to start Fivetran is basically like the end of 2014 is the earliest time you can start to sell it because you need Redshift to take off. Because that gives you all of these West Coast tech companies that are pretty small, setting up their first data warehouse for the first time. They don't have any preconceived notions of how ETL should work. They'll consider anything. So they're perfect like early adopters. And there was just this wave of them that year, because of Redshift taking off, and the next year. And that was the opening that we went into. So there was very much a timing element of it, but we were too early, and we solved that by just like cranking away on various ill-fated ideas, ill-fated variations of this vertically integrated data analysis tool until the timing became right.
There's like this window almost in history, kind of like right when you guys were starting through maybe a few years ago, where like enterprise data tools, and it's like a horrible generalization, but I'm just going to use it for a second, where you have companies had begun to shift. They had on-prem data, they had SaaS data, they had all these kind of like, alternative data sources where things lived. And there was just like a whole bunch of problems that created that, they almost like the enterprise data stack had to be rebuilt. And you had a lot of companies that were just kind of what you guys did, right? Smart, technical people who were just in the game in the beginning at the right time.
Yeah, and just found a piece of that and grabbed onto it. Yeah.
Yeah, exactly. And it worked, right? Clearly, like if you were really good at what you did, you could kind of like iterate your way to the idea. Do you think that time is over?
No.
Do you have to like really know what you're doing, or is there just so much free, endless field out there that can still work?
I think it's not over. I think that the actual like execution engines that run all these workloads are based on ideas from what is it? The first one was like MonadDB X100 from like 2003 or something. And a lot of things have changed in hardware. And I don't mean to be too dismissive or anything here. Like some big changes have been adopted. Like the separation of compute from storage is a really important idea that comes from changes in the hardware. But there have been some other changes in the hardware that have some pretty profound implications for how you build an analytical system that I would be worried about if I were selling an analytical database. Like the ground is shifting beneath our feet, or it shifted, and people are noticing that it shifted.
Interesting. You guys get that, like the hardware changes what software is capable of, and that changes the ability to deliver, and you get that like little cycle
and it changes the trade-offs. Something where you have a trade-off where like on the one hand, pro and con, and it drives you to a particular decision, but then the size of the pro starts shrinking, the weights of the things start to change, and when they cross the threshold, and now it flips the other way, and it's like, oh, now you want to do it the other way. And suddenly all of this work is invalidated. But it's going to be good for the ecosystem and good for the customer. Ultimately, all of us vendors just have to figure out how to navigate it. And the things I think you're going to see are you're going to see costs go down. You're going to see latency go down. You're going to see performance go up. It'll all become cheaper and faster and easier to use and have fewer compromises. I really look forward to the point when you can like go into Salesforce and like change something, and then go over to your other tab and like refresh your dashboard. And then the time it takes you to do that, like the data that you just edited has made its way over. Like it's super hard to figure out, to imagine that with today's technology, but people really want that. And I think it does not violate physics. Like it can be done. It's just going to take a huge amount of work, but people will love it once it is. Even if it isn't that necessary, people will love it. And so whoever can deliver on that will win.
It's coming. And it's not just in your dashboard, by the way. It gets updated in like every connected SaaS system, and it kind of, perpetuates out through the entire stack, and it's immediate, and there's no like downstream QA issues anytime you make like a schema change, and just, your entire system blows. I mean, these are all the things I remember doing in 2007, like just getting some of our own internal data from different systems into a warehouse that we could rely on and wasn't breaking all the time, anytime any source system made a change. I mean, it was a disaster, total disaster.
Some of the source change stuff is really tough because it's fundamentally about workflows and semantics, and there is no technical solution. Somebody has to talk to somebody else and explain what this thing means now. So some of that stuff isn't going to go away, like the broken dashboard, because somebody changed the source system. It's fundamentally a workflow problem. I guess it goes away. I shouldn't say that. It's just a different kind of problem. You have to build tools that allow people to coordinate these activities so that they don't break each other. So that right before, I joke, it's like the Salesforce administrator, right before they make the change, they get like an electric shock from their chair. Like, what are you doing? You're about to break everything downstream of you. And maybe that's a slight exaggeration, but somehow they find out like, oh, you can't just change that. Like, you have to go and coordinate with all these other parties.
Yeah, even just the linkage of what this change will downstream affect, because, especially in these large organizations, you're making a change over here. You're not aware of the 5,000 things that ultimately rely on that data, and just being able to say, hey, if you make this change, and ideally into like a queue where someone has to approve it, here are the 35 things that are going to break. And by the way, here are the people who are responsible for those things. We're going to make them aware before, when they have like in nuclear war, like both people have to turn the switch at the same time kind of thing. They just like knowing that, like, how to traverse what is connected to what and to who. That in itself right there is like a complicated problem where you have like services teams internally at some of these big enterprises just map that out for you.
The hard part about that, the thing I don't have an answer to for that is I think in order for that to work well, you really need to have testing be native to the workflow of each tool. Like, the Salesforce administrator really needs to see the error in Salesforce Sandbox after they make the change, but before they deploy it to production, right? I don't know if it's going to work if it's in like this data lineage, whatever tool that's somewhere else. Everyone's going to log into that, and they're going to like change the Sandbox, and they're going to have a separate Fivetran connection for the Sandbox, the lineage tool, and then the run test. I find it a little hard to believe that people are going to set up all these extra links in order to support testing. Testing, it's like eating your vegetables. People don't really want to do it. You have to make it really convenient. You have to like, toast those Brussels sprouts and make them look really nice to get people to eat them. And it's really hard for me to picture how this happens. I think Salesforce changes are like the hardest piece of this. And so anyone who's working on this, like, start there. Don't start with your production database. That's bullshit. I hate it when people, they're like, I have this great solution, data contracts or whatever for my production database. I'm like, yeah, that's the easy part. Tell me how you solve this for Salesforce.
It's really interesting to me that, like, when I ask is the low hanging fruit kind of gone, you actually point to hardware changes that are happening more than anything else. It's just like a very nuanced answer that I wouldn't have been able to answer myself. I kind of like appreciate the nuance there. Now I'm curious, which I'm not going to ask you on this call because I'm sure you don't want to give it all away, but that's like actually driving some of the stack changes that you expect to see.
No, I'll give it away. I think the fundamental, and I think that the problem you identified, which is the sort of testing problem, is actually just as big. It's just not one that I tend to gravitate. I tend to like pay attention to, because I'm such a nerd, and it's more of a workflow problem, but it's just as big. But the hardware change that I think is really invalidating a lot of the assumptions on which these systems were built is that almost that you can get such a large VM. You can get a VM with like 2 terabytes of memory, and that almost no one actually needs a massively parallel distributed processing system. You just need many of those, right? Like hardly anyone has a query that can't fit on one node. And that is just that unlocks a very different set of decisions that have huge benefits. If you only run on one node, then you don't have to do shuffles and you don't have to do all kinds of things. And you can get a lot of efficiencies and things can run faster. And so that is just a huge change that I think is going to really like mess with a lot of people.
That's fascinating. Like we made this assumption for a while that all of these giant data questions we had to be distributed in nature because the machines weren't big enough to actually like hold the data and run the query. And that was true. And now it is no longer true. And you've got like all these distributed. Yeah, that's interesting.
People fool themselves on this because they look and they say, oh, look at all this workload in this big warehouse. It's like, wait a minute. How big is the individual query? Because if you just have lots of queries that need to run simultaneously, you can distribute them onto a farm of independent nodes that each don't actually share information with one another. And then there are other things you can do. Even if you have one query that's too big, if it's only like 10 times too big, there's some tricks you can pull in order to take pieces of the workload and distribute it without having to tackle the really costly pieces of true distributed processing. It's like this giant like fork in the road, and everyone for years and years and years has gone down this path. And I actually think for like 99.9% of companies, the other path is probably, in theory, now the correct answer. The problem is you have to do like all years and years of just engineering work in order to sort of realize that promise. So it doesn't just happen one day. But I think that's really a space to watch.
Sorry, we bored Logan with the nitty gritty, but I love this stuff because like for me, this is the shit that actually matters when you're a founder. It's
totally.
like all those little nitty gritty details that nobody actually talks about in the press release or the website, but that's the nuance. That's the stuff that differentiates, Fivetran from the company that got bought for 1/100th of the price.
Well, the question I wanted to ask both of you, I guess, George, you and Taylor, your co-founder, have known each other, or your families have known each other for what? I've heard the story, 100 years or something, like same cabin, same.
More, in fact. Yeah. The cabins were built 100 years ago, but the families knew each other before that. Yeah.
So you guys your families have known each other forever. And Zach, I mean, you and Nat were what? Friends in college. And so one of the things like I feel people often say is like, don't risk your friendships or whatever going in on these businesses, particularly when there's generational relationships in place, right? It's one thing if it's like your next door neighbor that you play video games with. It's another if there's like family dynasties tied in together. I'm interested in, was that something that when you were starting this that you were actually concerned about, or was it refreshing to have a founder that you knew so well and there was such mutual trust?
For us, it was mostly just upside. There's like a deep reservoir of trust, and that was really important. And funnily enough, because of this extensive, it was not just us who know each other, it's all these relatives. Because of this, everyone knew what we were doing and was like all on top of it. And we realized, oh my God, we have to make this. It made that much more pressure to succeed. Because we would just never live it down. We'd be hearing, I'd be asking when I saw Aunt whoever once a year, she'd be asking, oh, it was too bad how that Fivetran thing didn't work out. I'd hear that like every year at that time of year for the rest of my life. Like that would have happened. And so it created a lot of pressure beyond what is already there. And you know what? Fear of failure is a very powerful motivator. So for us, it was really all upside. I can understand how it could go wrong, but it's worked really well.
I think these like rules about, co-founders or solo founder or married founders or, related, it's all bullshit. Like you can do this in a variety of ways as long as the people are just really, really smart. And there's like three things that matter in my opinion. Like they've got to be very smart. They've got to have just like a drive to get shit done constantly. And that's whether it's like my aunt is going to be, never letting me live this down, or I dropped out of college in my case, or whatever. Like there's just got to be something in the back of your head going like, don't fuck this up, don't fuck this up, don't fuck this up. And you have to have the capacity to do it on the skill side. And then I think there's like an ethical component, which is, especially from co-founders, which is like, you're going to make a bunch of decisions that affect the other person. And you just need to have trust that like, even if you make the wrong decision, you did it for the right reasons. And I think if you have some combination of the three of those things, it doesn't really matter if you're, hundreds of generations back. That's a kind of a crazy story.
Hundreds.
Or you just met in college, or you're married.
5, I think.
Yeah, whatever. back in where the Vikings were fighting. But like, yeah, I just think you can kind of do it in a bunch of ways. It's more about the personality traits of the people than the like, the setup. I that's at least been my experience.
Towards your earlier point, it's really the details that matter. These broad principles are always wrong.
Yeah.
This co-founder configuration is incorrect. For every form of that statement, you can go find a counterexample. It's the details that matter.
Well, Cisco, they were married, right? And that's one of the biggest enterprise companies ever. So
you can't ever have co-CEOs. Well, have you heard of Workday? Right? Like you should never take the founders and put some like old school MBA in charge, Eric Schmidt.
Now, one other one I just picked up along the way, but you went to Lawrenceville, right? You grew up in New York, or you grew up in Rye. You were born in New York. Is that right?
Mm-hmm. That's right.
Lawrenceville boarding school in New Jersey. It seemed like you had family that had gone there over the different, maybe your dad went there. Is that?
Mm-hmm. Yep.
It seemed like that was a somewhat impactful, formative, like high school is for a lot of people, but it seems like you had a reverence to that experience in some way. Can you talk a little bit about like boarding school and why it was such a good experience for you and any impact it maybe had today?
Yeah, I mean, it was a very special place, a very special institution. It gave a great education. Really, that was my liberal arts education. College and graduate school were something totally different. And it also, there's a tremendous sense of history at these old East Coast boarding schools and of like destiny almost. You go there and you feel like you're meant to do great things. Everyone here is meant to do something important. And I think that really stays with you. So for me, it was a great experience.
I'm picturing Hogwarts and Dead Poet Society and all of that stuff.
Definitely people refer to it as like Harry Potter with no magic. That's not inaccurate. And one of the characters in Dead Poet Society, supposedly, this, may be bullshit, but supposedly was based on a friend of my dad's from Princeton, who went to not Lawrenceville, but a different boarding school. So, you're on target.
Interesting.
You spent 6 years getting your PhD, right, in neurobiology, which for another
5.5.
5.5. And one of the things I heard you say was that the randomness of academia was almost like a daunting thing, or it just seemed too abstract in terms of how people actually succeed. And so you wanted to go down the entrepreneur path because of that. Can you talk a little bit about like academia and sort of doing that for 5.5 years is a long time, right? And going down that path and then ultimately deciding to be an entrepreneur?
Well, I went to graduate school and I did graduate. I am Dr. Fraser. But no one calls me that except my boyfriend, because he also has a PhD that no one calls him by. I mean, he calls me Dr. Boyfriend. So,
that's funny.
But by the time I graduated, I had decided to go into the private sector, and the reason was basically what you said. I watched other people who were further along, and who actually succeeded in getting the tenure track faculty positions that you need in order to be a full-time researcher. Seemed extremely random. Like there were some great people who got these jobs, but there were also terrible people who got these jobs. I was like, that guy got a tenure track faculty job? How? And vice versa. I would see great people just fail and fail and fail. And it was like, what are the rules of this system? I don't understand. Startups, well, also containing a large degree of luck and randomness, and also having a very low success rate, they do follow rules. Like at the end of the day, it's the customer who decides whether they want to buy your thing or not for themselves. It's not someone passing judgment on whether you are good, right? And so that there was something appealing about that. It's kind of you make your own destiny.
The other really interesting thing about academia, I found really interesting, I'm curious if you felt this, was the promotion decisions, similar to what you were talking about, were not based on any sort of like rigorous interview, any sort of like structured evaluation process, all the things you end up having to put in place in a company because, if you don't have standard clear processes for how people get promoted or paid, there's politics and cultural issues, then the whole system kind of breaks down. But academia kind of doesn't really have any of that. There's almost no structure and process. It's completely amorphous, if you will. And it's just really shocking to me that we haven't come up with a like, hey, if we're going to think about who gets like a tenure track position in chemistry, maybe we should actually test their understanding of chemistry at that level. Like we should have rigorous interviewing, and it doesn't seem to exist in any way. You just look at like the papers they published essentially.
Well, I think once the people get tenure track positions, it is fairly, that is fairly straightforward how it works. It's publishing papers in high impact journals.
Yeah.
And getting grants. That's it.
I don't know. It just it felt like.
But I have no quarrel with that. It's more kind of the initial gate that was bizarre to me. Although then at the second layer, the grant process and the paper process is also very bizarre. Like what succeeds and what doesn't.
Hey, one thing I wanted to ask about was you guys acquired a fairly big company, about a year ago now?
It was 1 year. The deal closed 1 year ago, like 3 days ago, something like that.
So your round was 5.6 billion at the time. You cash and stock of 700 million. You guys disclosed at the time for HVR. So rough math, 12.5%. Typically, not to do the VC platitude thing that I did earlier, but I mean, private to private acquisitions in general are hard, right? Acquisitions of a big scale are hard. And doing this type of thing in general is hard. You're a year in now. Any lessons that like things that you didn't expect going in to doing that, that you maybe got lucky with that worked out, and things you wish you had done differently?
I don't know. It's gone pretty well. Most of the advice we got about this is what makes acquisitions work or not work was right. And we very diligently followed it.
Which was what? What did people tell you?
There's so many different pieces of it. That the compatibility of the culture is very important. It's not just about the sort of market and the technology and that logic, but if the company cultures are not compatible, one of them will just eat the other.
How many people were on each side when the acquisition happened?
Man, HBR was 100 and we were I don't know, 600, something like that.
So proportional roughly to
maybe a little more than that.
Yeah.
And we went in knowing that the cultures were mostly compatible and there were maybe some pockets that were going to be a little different, and that those predictions pretty much turned out right.
Yeah.
There was one big surprise. The technology was surprisingly compatible. We knew that there were a lot of similarities under the hood, but it turned out once we actually looked at the source code that both systems convert all the data they ingest into an intermediate representation internally. That is like an update or an insert and a bunch of other things. The details are very important and very specific. And they were identical. It was how alligators and crocodiles actually are not related. They just both evolved to live in swamps. And so they look the same. It was like that. We had just co-invented the exact same internal representation with one exception. There's a thing that happens in APIs that just never happens in databases. HBR was all about databases. But that was really convenient and helpful in terms of getting a integrated product up and running quickly. And quickly meant 6 months, right? But that's fast.
Was doing it during COVID helpful, or was it harder? We were still sort of in the middle of Omicron a year ago, right? And people were definitely working from home. Did that make it easier to get everyone on the same page and not have to worry about locations to the same extent? Or was it harder?
Well, the definition of COVID being over, I think, varies from person to person. In my view, COVID was over at that time. And I think most people at the combined company felt that way. And so we spent a lot of time together. And I know there are some people who are going to feel that COVID is not over forever. But I think I would disagree with the premise of that question. We had a giant in-person event for the entire company not that long after the acquisition closed, Camp Fivetran, which is a very special part of our culture that we've done for many years. And it was conveniently timed to be right after the acquisition. That worked out well.
Yeah.
And we had sales kick off the next year, same as usual. And that was a great opportunity for people to meet and spread Omicron to one another.
Yeah, totally. That's the way all good company cultures bond over the last couple of years.
Right.
Well, thanks for doing this. This was great. Thanks for letting us go in so many unstructured ways here.
George, good to meet you.
No problem. It was fun.